Hi everybody, I hope this video finds you well. This will be the sort of last video on the section about conditional distributions and conditional analysis. All we're going to be doing in this video is just taking a quick look at sort of an interesting thing that can arise when doing conditional analysis. This is strongly related to the idea that when we talked about like correlation and regression, or even when we talked way back about statistical studies in general, we sort of talked about how when you're doing an observational study, there's always the potential for sort of lurking or confounding variables. In other words, variables that you didn't take into consideration in your analysis, but are very important. And we're going to see an example of that in sort of conditional analysis when working with categorical variables. Mathematically, this sometimes gets the name Simpson's paradox. Paradox is just sort of a name for things where we take something that looks logical on the surface, but then get some very sort of illogical type conclusions. And then usually in the study of sort of logic, you have to try to come up with a resolution for the paradox. And we'll see that in Simpson's paradox, which is sort of the name for this, there is a pretty easy resolution to the sort of strange things that we see. So we're going to do an example to sort of put all that into a little bit more of an easy to understand context. So we're going to suppose that you are studying crime fighting in Gotham City. So what you do is you follow around the two most famous crime fighters in Gotham City, Batman and Robin, and you watch them each attempt to solve 200 cases. So if you're familiar with the comics, 200 cases would happen in the span of like a day or two in Gotham City. Seems like a terrible place to live. So you watch both of these crime fighters go and attempt to solve 200 cases, and then you get the following data. So here's your sort of data for Batman, right? He solved 180 of the cases he attempted and did not solve 20 of them. And Robin solved 185 and did not solve 15. So this is a very small example of a two-way table where there are two categorical variables. Which crime fighter did you look at, Batman or Robin, and whether or not they solved the case that they were working on. We know that with these two-way tables, we can get the different sort of totals here. So we can see that overall Batman did have 200 cases, right? 180 plus 200. 185 plus 15 is also 200. We can also see that together, the two crime fighters solved 365 cases and failed to solve 35 cases. And then, of course, we know that the table total overall would be 400 because they each worked on 200 cases, which means 400 cases overall were looked at. So let's go ahead and take this information and try to determine, using this, who was the sort of better crime fighter. So let's talk about sort of getting Batman's success rate. So we want to get a percentage that sort of the cases that Batman attempted, how many did he solve? So notice what we're doing is we're doing a conditional analysis. We're going to look at Batman's cases, 180, but we're not going to divide by 400 because he didn't work on all 400 cases. He worked on those 200 cases. So we're using this as sort of the column, going column by column, or using the column totals here. And that's because the explanatory variable would be which crime fighter, Batman or Robin, were you looking at? So Batman's success rate would be 180 out of 200. He solved 180 successfully out of the 200 he attempted. If you wrote that as a percentage, you would get 90%. So Batman apparently has a very good success rate. He solves 90% of the cases he works on. Let's check Robin. So Robin's success rate, well, that would be his 185 cases that he worked on, that he solved, out of the 200 that he worked on. So it would be 185 out of 200. And if we type that into the calculator, right, we should get that his success rate was 92.5%. So we can see that while Batman's success rate was 90%, Robin's success rate was a little bit better, 92.5%. So according to this, right, according to this, Robin seems like the better crime fighter. Now, of course, right, we might be a little surprised by that, right? And if everything we've ever heard about these two sort of crime fighters is that Batman is the actual sort of superhero and Robin is just sort of his sidekick. So it's a little surprising that we see this data that's sort of saying that Robin has a higher success rate than Batman. Now, obviously, one answer to that is maybe we've been lied to all this time about, you know, who's really the top between Batman and Robin. Or maybe, you know, I just don't know anything about Batman and Robin, and I accidentally made the mistake that Robin has a better success rate. Unfortunately, neither of those are really the answer here. Instead, we might want to consider if there's sort of a missing other variable here. So what I want to sort of imagine is, what if we sort of saw this data and went, that doesn't seem to make sense. We know Batman's the superhero and we know Robin's the sidekick. What else could be going on? Well, maybe we would take a look at our data further and realize, well, maybe they worked on different sorts of cases. So let's imagine that we went back over our data that we had here, this data about these 200 cases for each, and we sort of divided the cases into sort of difficult and easy cases. So let's suppose we reanalyzed according to easy and difficult cases. Okay, so let's suppose that when we go back over our records, right, and we see the easy cases, right? So we have our solved and did not solve, and we have Batman and Robin, right? Say that when we go back over our data, right, we find out that for the easy cases, Batman solved 10 easy cases, and he failed to solve 0 easy cases, while Robin solved 180 easy cases and did not solve 10 cases. All right, and then let's say over here for sort of difficult cases, all right, solved, did not solve, and then there's Batman, there's Robin, and make ourselves our nice little table there. All right, let's say that Batman here solved 170 difficult cases and failed to solve 20 difficult cases. And then Robin solved 5 difficult cases and failed to solve 5 difficult cases. Now, obviously, we don't actually have these 200 cases or the information about these 200 cases. So how do we know that this data here sort of matches this data here? Well, let's check. If we look at Batman, in the easy cases, he solved 10. And if we look at Batman in the difficult cases, he solved 170. 10 plus 170 is truly that 180. Same thing for the cases he didn't solve. He didn't solve 0, he didn't solve 20, so that adds up to 20. So that 180 and 20 really could break down as 10 and 0 and 170 and 20. Let's check the same thing for Robin, right? Solved 180 here, solved 5 here, add those together, you get that 185. Failed to solve 10, failed to solve 5, add those up, failed to solve 15. So this data down here, even though we've added this extra variable, easy and difficult cases, we still have the same overall data. So these are new two-way tables, so let's quickly just sort of get all the information we want here. So this would be 10 and 190, and of course this would be 190 and 10, and that's going to be 200 there. And then we've got, 175, 25, 190, and 10, and that would also be 200 there, right? So apparently there were 200 easy cases and 200 difficult cases. In the easy cases, Batman worked on 10 of them, and Robin worked on 190. For the difficult cases, Batman did 190 and Robin did 10. So let's get their success rates in each of these different cases. So if we do Batman's success rate, right? Well, he solved 10 out of 10 easy cases. So that would be 10 out of 10, which is 100%. Apparently, he solved 100% of the easy cases he worked on. For Robin, right, the success rate, well, did 180 out of the 190. So 180 out of 190, which if we check there, also should be a pretty high rate, 180 out of 190. Looks like it's about 94.7%. So we notice that in easy cases, both of them did it very, very well because, again, they were sort of easy cases. But we'll notice that Batman had an 100% success rate, which is definitely better than the 94.7% success rate. Let's check over here. So if we do Batman's success rate, well, he successfully did 170 out of the 190 that he worked on. So that would be 170 out of 190. And if we do that, 170 divided by 190, looks like we should get 89.5%. And for Robin's success rate, well, he successfully handled 5 out of the 10 that he worked on. So if we do 5 out of 10, right, we'll see that that is 50%. So notice, of course, both of their success rates are lower when they take on difficult cases, but notice that Batman's success rate is much better than Robin's. So we should sort of note, Batman is better in each situation. So this right here is the sort of paradox, right? We can see that when we break it down into easy and difficult cases, Batman is better in each situation. He's better at solving the easy ones, 100 versus 94.7, and he's better at the difficult ones, 89.5 versus 50. Yet overall, right, Robin has a higher success rate of 92.5 versus 90. So what's the resolution to this paradox? Well, it's clearly in sort of which types of cases they take on most frequently. We saw the massive disparity in this. For easy cases, Batman only worked on 10 of them. Robin worked on 190. So notice that his overall success rate, 92.5, is very close to his success rate for easy cases, because that's mostly what he works on. Whereas for Batman, right, Batman's success rate, that 90%, is very close to his success rate for difficult cases because that's mostly what he works on. So in other words, right, it's not really fair to sort of compare their overall success rates because Batman is taking on the really challenging cases and Robin is taking on the cases that might be like getting cats out of trees or something, right? So it's not really fair to look at their overall success rates because this other variable of the difficulty is sort of also very important in the explanation. So this is something that's very important because when you do standard conditional analysis, you only have access to 2 variables. But there is always that sort of potential that maybe there's a third important variable, in this case the difficulty of the cases they were attempting, that might be sort of impacting the data. Now, of course, this is sort of just a silly example with crime fighting and Batman and Robin. I do want to give you guys just verbally sort of one actual case of this. There's sort of a famous case of Simpson's paradox in statistics when people were analyzing like ambulances versus helicopters for medical emergencies. There was some data coming out where different like health organizations were looking at whether or not they should invest in helicopters. And they looked at national data about sort of the survival rate of patients that went into an ambulance versus going into a helicopter. And the idea was that probably more people survived when they went into a helicopter because it would be a sort of faster mode of transportation. And of course, from the sort of hospital's perspectives, they hoped that was the case because helicopters are much more expensive than having ambulances. However, when they looked at the sort of national data, they found that actually the survival rate for patients in helicopters were lower, generally, than those for ambulances. And at first, the sort of consideration was, oh, that must mean that helicopters don't work that well, right? In other words, we shouldn't spend the money to invest in helicopters for hospitals. But of course, on further analysis, what they found is that there was sort of another case of this sort of Simpson's paradox here. What was happening is that helicopters were being deployed in more severe of situations, whereas ambulances were being deployed in less severe situations. So what this meant is that helicopters were better in their individual situations, but they were being assigned more difficult situations. So it wasn't really fair to compare their overall success rates, just like it wasn't really fair to compare Batman and Robin's overall success rates. So it's just something to really sort of consider when you're doing this conditional analysis, in that there could be other variables sort of behind the scenes.